Per VLAN spanning tree is a fantastic way to get those other links in action, and so are ether channels. You're going to love these. We're going to talk about what an ether channel is for just a few minutes, and then we'll configure one live. We'll see potential issues that could come up with them, and then we're going to verify the heck out of them. And a lot of work here with ether channels in the lab. But let's go over some theory here for just a few minutes so we know exactly what's going on with them. This is a logical bundling. And the term we use for this is aggregation. If you haven't heard that term before, it's a good one to get used to. Aggregation is just a fancy way of saying we're taking some individual units of something and we're putting them together. And in ether channel, what we're doing is taking 2 to 8 parallel Ethernet trunks and we are putting them together into one logical channel. And there are two huge benefits here. The first one, of course, is greater throughput. Because if you have 8 trunks, we know by default only one of them is going to be used. And that's 7 trunks just sitting there, and while we appreciate the backup, we'd rather just use the paths in the first place. It's also an effective way to avoid that 50-second wait between blocking and forwarding states in case our one open trunk goes down. So how are we avoiding this delay? What happens is FTP is going to look at an ether channel as one physical link. We'll actually see that when we're running show commands on the live switches, that instead of seeing the individual trunks we've gotten used to in these labs, you're just going to see one link. And we're going to have 3 crossover cables, but we're just going to have one link representing all 3. The great thing is if one of the physical links in the ether channel fails, then STP will run a recalculation as far as the cost goes, because we don't have as much speed, right? We know that port cost is always going to be determined by the speed of the link. Well, the cost will change, but there's no having to bring anything out of blocking and then listening and then learning and then forwarding, because as far as STP is concerned, the link didn't go down. It just got a little bit slower. We'll see that on the live equipment here shortly. We're going to have 2 switches separated by 3 crossover cables, just like this, switches 1 and 2, and I have removed all other cost commands, and the only VLANs that we have on here now, I believe, are still 1 and 100. But the VLANs really don't come into play here. Now, I've got this in the book, but we'll see that live in just a moment. But this is the part I want to go over with you before we hit the lab. We have 3 physical connections, and we know by default only one is going to be used. We also know that if the root port on the non-root goes down, we got to wait 50 seconds for another one to come back up, and that's a long time for a trunk to be down. So again, by putting all 3 of these ports into a single logical link, we get to use all the bandwidth, and if a single link fails, then we don't have a huge STP recalculation. We don't have to go from blocking to forwarding. Actually, we'll probably really mess with ether channels and go ahead and shut 2 links down inside of one and see what happens. That's the joy of a lab. You can do that kind of thing. One thing I want to mention before we hit the lab. It's really kind of odd because I've said a couple times in the course and probably will say again, you have to get used to things in networking having more than one name. Well, here's the thing. This is called an ether channel, but you won't see the switch refer to it as an ether channel, and you won't be using a ether channel command to configure it. You actually create the ether channel with the channel group command. Then when we look at the config, you're going to see it referred to as a port channel, and we won't even see the word ether channel until we're finally running some verification commands at the very end of the process. So channel group, port group, ether channel, all referring to the exact same thing. And in the very next video, we will start on the live equipment. We'll build an ether channel. Like I said, we'll mess around with it a little bit and then just see how STP reacts to some ports getting shut down. I'll see you on the next video, and we'll hit the lab.